A universe vast and unknowable stretches infinitely in all directions. Stars drift across the endless void, locked in a cosmic ballet dictated by forces far older than time itself. But what if time isn't what we think it is? What if everything we know about time, its past, present, and future, is an illusion? Right now, the atoms that make up your body are older than the Earth itself. Some of them formed in the heart of ancient stars, scattered across the galaxy before eventually becoming part of you. But despite their age, those atoms show no signs of wear, no evidence that they've traveled through billions of years. They exist in a strange state, one that defies everything we assume about time. If an atom cannot age, cannot decay unless forced to, does it truly experience time at all? Or are atoms, the very foundation of our reality, trapped outside of time, frozen in a quantum prison? Time, as we experience it, is an unstoppable force. We age, we move forward, we remember the past but cannot revisit it. The arrow of time pushes everything in one direction. But deep in the subatomic world, where the rules of quantum mechanics reign supreme, time does not appear to exist in the way we understand it. A particle's movement isn't dictated by the familiar progression of seconds, minutes, and hours. Instead, quantum mechanics suggests a reality where time is malleable, where events can be reversed, and where the past and future may be indistinguishable. Scientists have observed particles interacting in ways that suggest they aren't bound by time at all. Some quantum interactions seem to influence the past after a decision is made in the present. Entangled particles, no matter how far apart, appear to communicate instantaneously, without delay, without a moment passing. How is this possible? And more importantly, what does this mean for the fundamental nature of time itself? There is something unsettling about the idea that time might not be as rigid as we assume. If time can be manipulated, if time is nothing more than a byproduct of something deeper, what does that mean for everything we know? Does time exist only because we are here to perceive it? Or does the universe itself dictate the passage of time, trapping all things, including atoms, within its invisible grasp? It is a question that has haunted physicists for over a century. From Einstein's theory of relativity to the bizarre experiments of quantum mechanics, time remains one of the greatest mysteries of science. It seems unbreakable, yet the deeper we look, the more it appears to be an illusion. And if time itself is an illusion, then what happens to the atoms that make up reality? Are they truly moving through time, or are they simply existing in a state beyond it? In this journey, we will explore the quantum strangeness of time, the paradoxes that arise when we look too closely, and the ultimate question that has puzzled humanity for centuries. Are atoms, are we trapped in time, or is time itself the greatest illusion of all? Time is something we take for granted. It moves forward, never backward. It carries us from birth to death, from past to future, without pause or exception. It governs the rise and fall of civilizations, the movement of celestial bodies, the ticking of a clock. We measure it, plan our lives around it, fear its passage, and long for more of it. But beneath this comforting illusion of time's inevitability lies something far more unsettling, something that challenges the very nature of reality itself. For centuries, humanity believed time was absolute, a universal constant that dictated all movement, all existence. Days followed nights, seasons changed, the stars followed predictable paths across the sky. Even the greatest thinkers of ancient civilizations saw time as a fundamental, immutable force, something that simply existed without question. But then, in the early 20th century, everything changed. Albert Einstein shattered the illusion of absolute time with his revolutionary theory of relativity. He showed that time wasn't a rigid, universal force, it was flexible, woven into the very fabric of space itself. Time could slow down, speed up, stretch and contract. And more disturbingly, time could be experienced differently depending on how fast you moved or how close you were to an enormous gravitational force. This discovery was more than just a scientific breakthrough. It rewrote the fundamental understanding of how the universe works. Imagine a twin traveling through space at near the speed of light while the other remains on Earth. If the spacefaring twin returns decades later, they may have only aged a few years while their sibling on Earth has grown old. Time, once thought to be the same for all observers, is relative. But as groundbreaking as Einstein's discovery was, it was only the beginning of an even stranger and more disturbing revelation: the realization that, at the deepest levels of reality, time might not exist at all. While relativity describes time's flexibility on the cosmic scale, quantum mechanics does something even stranger. It removes time's certainty altogether. If the rules of the macroscopic universe are dictated by relativity, the rules of the microscopic subatomic world are dictated by quantum mechanics. And in this world, time becomes an enigma. An electron orbiting a nucleus doesn't move the way a planet orbits a star. It doesn't follow a clean, predictable path. Instead, it exists in a cloud of probability, existing everywhere and nowhere at once until it is observed. Its position, its momentum, its very existence in time is uncertain. But it gets even stranger. In certain quantum experiments, scientists have found that particles can be measured in a way that seems to affect their past. The famous double-slit experiment shows that particles behave differently depending on whether or not they are observed. When not observed, a particle acts like a wave, existing in multiple places at once. But the moment it is measured, it chooses a specific position. Even more bizarre, in some versions of the experiment, the choice to measure the particle seems to retroactively affect its behavior, as if the future is dictating the past. This suggests that at the quantum level, time does not work the way we expect. Past and future may not be as rigidly defined as we think. If time is not absolute, if it can bend, stretch, or even be rewritten, then what does this mean for atoms? Do they truly experience time? If an electron exists in a cloud of probability, never in one place until measured, does it also exist in multiple points in time? When we say an atom is old, are we merely projecting our own perception of time onto something that doesn't experience it at all? To understand this mystery, we need to look at entanglement, one of the most baffling aspects of quantum mechanics. When two particles become entangled, they share an invisible link that allows them to instantly affect one another, no matter how far apart they are. If one particle is measured, the other immediately responds, even if it is light years away. The connection between them is instantaneous, faster than the speed of light, faster than any signal could possibly travel. But this raises a troubling question. If information is exchanged between entangled particles instantly without delay, then does time even play a role? If one particle can know the state of another across vast distances with no passage of time in between, does this mean that, at some level, time does not exist? Some physicists believe that entanglement may hold the key to understanding time itself. If atoms, the very building blocks of the universe, can exist in a state beyond time, does that mean time is simply a feature of human perception? And what about decay? We are taught that atoms can decay, that radioactive elements like uranium will eventually break down into smaller, more stable particles. But even this process is dictated not by an absolute timeline, but by probability. A single radioactive atom doesn't decay at a fixed moment. Instead, it has a chance, sometimes a very small chance, of decaying at any given moment. The only certainty comes from large numbers. A sample of radioactive material has a half-life, the time it takes for half of the atoms in a sample to decay. But for an individual atom, there is no set expiration date. It could last a second. It could last 1 billion years. The moment it decays is not determined by any physical clock, but by a roll of quantum dice. And yet, despite all of this uncertainty, we still experience time as something that moves forward. We still age. We still watch the hands of a clock turn. We still remember the past, but not the future. But why? If atoms, the fundamental components of everything we see, do not experience time as we do, then where does our perception of time come from? Is time an emergent property, something that only arises at a macroscopic level? If we were to somehow see the universe from the perspective of an individual atom, would we witness time unfolding at all? It is this question that leads to one of the most profound and unsettling ideas in all of physics, the possibility that time itself may not be fundamental. Some physicists believe that time is not a real physical dimension of the universe, but rather a human construct, something that only exists because of our limited perception. If true, then atoms, the very foundation of reality, may be immune to time's passage. They may exist in a state beyond time, neither young nor old, neither in the past nor the future, but simply existing. And if that is the case, then what does that mean for us? Are we trapped in time, unable to escape its relentless march forward? Or is time itself an illusion, a shadow cast by something even deeper and more mysterious? In the search for answers, we will unravel the nature of time itself, from the paradoxes of quantum physics to the strange effects of relativity. And in the process, we may discover that the truth about time is far more unsettling than we ever imagined. If time is not an absolute force, if it can bend, stretch, and possibly even cease to exist at the quantum level, then what are we actually experiencing when we perceive time passing? What gives time its apparent direction? Why can we remember the past but not the future? Why do we experience time as a flowing river instead of a frozen lake where all moments exist simultaneously? Physicists have long struggled with these questions, and many believe the answer lies not in the fundamental laws of physics, but in something far stranger, something that doesn't seem to exist at all at the atomic level: entropy. Entropy is often described as a measure of disorder, but more precisely, it is a measure of how many ways a system can be arranged. It is the reason that a shattered glass never reassembles itself, why smoke never gathers back into a match, why heat always flows from hot to cold, never the other way around. It is entropy that gives time its arrow, its one-way direction. But here is where things get strange. At the atomic level, the fundamental laws of physics do not require time to move forward. The equations describing atomic interactions, the movement of electrons, even the forces governing particle physics, these laws work just as well in reverse as they do going forward. There is nothing in quantum mechanics that says time must move in one direction. So if the microscopic world does not enforce time's flow, then what does? Why do we remember yesterday but not tomorrow? One answer is that the universe itself is evolving in a way that increases entropy. The cosmos began in an extremely low entropy state, an ordered state, and has been increasing in disorder ever since. But why did it start that way? Why didn't the universe begin in a state of maximum disorder, where no structures could form, no planets, no galaxies, no life? Why is the universe arranged in such a way that we experience a clear passage of time? Could it be that time itself is not fundamental, but instead an emergent property, something that only appears when you step back and view reality on a large scale? If time emerges from entropy, then does an atom, an individual, isolated atom, experience time at all? A single hydrogen atom drifting alone in the vast emptiness of intergalactic space has no entropy of its own. It does not age. It does not decay unless acted upon. It simply exists. Without anything to interact with, without a system to change, does time have any meaning for that atom? If there is nothing else around to measure it against, could we even say it is moving through time? Now imagine something even stranger. What if you could take a collection of atoms, arrange them in exactly the same way they were in the past, and reverse their motion at a quantum level? Would time itself reverse? Would events unfold backward? Theoretically, if we could perfectly reconstruct every atom, every quantum fluctuation, every microscopic detail of a system, we could make time run in the opposite direction. In fact, some physicists believe that in certain corners of the universe, perhaps within black holes or hidden in deep cosmic voids, there could be regions where time runs backward. But if this is true, then why don't we ever experience time reversing? Why don't we ever see atoms suddenly reassembling into their past states, erasing entropy instead of increasing it? The answer might lie in the quantum realm, where probabilities dictate everything. Even if time reversal is possible in theory, the probability of all atomic interactions aligning perfectly to undo time is astronomically low. In other words, it is not forbidden. It is simply so unlikely that it will never happen on any scale that we could observe. And yet, there are hints that time might not be as linear as we assume. The Wheeler-Feynman absorber theory, a radical idea proposed by physicists John Wheeler and Richard Feynman, suggests that every particle in the universe is influenced not only by the past, but also by the future. That is, an electron moving through space is being guided by waves traveling backward in time just as much as by waves moving forward. If true, this would mean that particles, atoms, are not simply moving through time, but are connected across time, influenced by events that have not yet happened. This idea becomes even more compelling when we look at quantum entanglement, the mysterious connection between particles that Einstein famously called spooky action at a distance. If two entangled particles are separated by vast distances, measuring one instantly determines the state of the other, no matter how far apart they are. This appears to violate the very concept of time itself. How can something affect another thing instantaneously across space without any delay? Some interpretations suggest that entanglement is not just a connection across space. It might be a connection across time as well. The two particles may be entangled not only in position and spin, but also in their place in time. Could this mean that information, or even cause and effect, is not bound by the forward progression of time? Could an atom in the present be influenced by an event in the future? If so, then our entire understanding of time might need to be rewritten. This leads to an even more mind-bending question. If atoms do not age, if their quantum properties ignore time, and if entanglement may allow connections across past and future, then why do we, as conscious beings, experience time so differently? Why do we seem to be trapped in time while atoms remain free? Could it be that time itself is a construct of the human mind, something that emerges only because of how our brains process information? Neuroscience suggests that our perception of time is closely tied to memory. We remember the past, but we do not remember the future. But this is not a law of physics. It is simply how we are wired. If our brains were structured differently, could we perceive time in an entirely different way? Could we exist outside of time, much like an atom appears to? If time is not fundamental, if it is something that emerges from entropy, from quantum mechanics, from human perception, then what happens if we learn to manipulate it? Could we unlock new forms of technology that allow us to step outside the flow of time? Could we use entanglement to send information backward, effectively creating a form of quantum time travel? Could atoms themselves hold the key to a future where time is no longer a barrier but a tool? These are the questions that push the limits of modern physics. They force us to confront the nature of reality itself. We assume that time moves forward because that is how we experience it, but the deeper we look, the less certain that assumption becomes. What if time, as we know it, does not exist at all? And if that is the case, what does that mean for us? Are we beings of time forever moving forward, or are we like atoms, free from the constraints of past, present, and future, existing in a universe that defies our understanding? In the next section, we will explore the most extreme environments in the cosmos, black holes, neutron stars, and the very edge of the observable universe, to see how time behaves under the most extreme conditions. And what we find there may change everything we think we know about time's true nature. If time is an illusion, a construct shaped by entropy, relativity, and quantum mechanics, then what happens to time in the most extreme environments in the universe? What happens to time at the very edge of reality, inside black holes, around neutron stars, or at the boundary of the cosmos itself? If atoms are not bound by time in the way we are, do they behave differently under these extreme conditions? To understand time's limits, we must first examine one of the most terrifying places in the universe, a black hole. A black hole is a gravitational monster, a region of space where gravity is so intense that nothing, not even light, can escape. It is the end of physics as we know it, a place where the laws that govern the universe begin to break down. But more than anything, a black hole is a place where time itself ceases to function in any recognizable way. Imagine falling toward a black hole. At first, time seems to pass normally. But as you get closer, something strange happens. From your perspective, everything seems fine. But to an observer watching from a safe distance, you appear to slow down. Your movements become sluggish. Your clock ticks more slowly. As you approach the event horizon, the point beyond which nothing can return, your time slows to a near standstill. From the perspective of the outside universe, you would never actually cross the event horizon. Instead, you would appear frozen in place, stretching infinitely into time, forever on the verge of falling in. But for you, something even stranger happens. From your perspective, time outside the black hole speeds up. The universe around you appears to age rapidly, stars burn out and die, galaxies shift and fade. If you could somehow survive the fall, you might witness the entire future of the universe unfold in mere moments. But once you cross the event horizon, time has no meaning at all. There is no past, no future, only a singularity, an unknowable point where all concepts of time and space collapse into nothingness. And yet the atoms that make up your body, the very building blocks of existence, continue to obey the fundamental laws of physics. They do not age. They do not experience time the way you do. If an atom could think, would it perceive itself as frozen? Would it even notice the passage of time at all? Could it exist in a state beyond time, unaffected by the destruction happening around it? But black holes are not the only places where time behaves strangely. Neutron stars, collapsed remnants of massive stars, offer another glimpse into time's distortion. A neutron star is an impossibly dense object, a ball of neutrons packed so tightly together that a single sugar cube-sized piece would weigh more than a mountain. Gravity here is intense, nearly as strong as that of a black hole, and time dilation is extreme. A clock placed on the surface of a neutron star would tick far more slowly than a clock floating in space. To an outside observer, time on the neutron star moves sluggishly, while the rest of the universe races ahead. If atoms are indifferent to time, what does this mean for the matter trapped in these environments? Do the atoms within a neutron star exist outside of time, immune to its flow? Do they persist in a state where time has no meaning? And if they do, could this mean that time itself is nothing more than a side effect of our perspective, something that emerges only when we look at the universe from the right scale? The mysteries of time do not stop at black holes and neutron stars. They extend to the very fabric of the universe itself. Scientists have long speculated that at the edge of the observable universe, at the farthest reaches of cosmic expansion, time may function differently. As the universe expands, distant galaxies are carried away at incredible speeds, some moving so fast that their light will never reach us. These galaxies are receding from us at faster than the speed of light due to the expansion of space itself, effectively placing them outside of our time. What happens to an atom in one of these unreachable galaxies? Is it still bound by the same rules of time as the atoms here on Earth? Or is it in some way lost outside of time, existing in a region of the universe where time has a different meaning. If time can be stretched, slowed, or erased in different parts of the universe, then what is the true nature of time itself? Is it a physical force like gravity, or is it something far stranger, an emergent property, something that arises only because we are here to observe it? This brings us to another paradox, one that lies at the heart of quantum mechanics and relativity. If time is relative, if it can be stretched and compressed based on motion and gravity, then what does this mean for the fundamental laws of physics? Are they truly constant, or are they also dependent on time's strange flexibility? Consider this. If time is an emergent property, then could it have a beginning and an end? We assume time stretches infinitely in both directions, but what if it does not? Could there be a point at which time itself stops? Some physicists believe that in the distant future, as the universe continues to expand and cool, time may eventually cease to exist. If all energy is used up, if all particles fall into equilibrium, then there would be no movement, no entropy, no change. And if there is no change, then time has no meaning. But if time can end, does that mean it had a beginning? Could time itself have been created? The Big Bang marks the beginning of the observable universe, but was it also the beginning of time? Or did time exist before the Big Bang, stretching into an eternal past? And if atoms are not bound by time, were they always here in some form? Perhaps the most unsettling question of all is this. If time is an illusion, a construct that emerges only under the right conditions, then what does this mean for us? Are we nothing more than beings trapped in a perception of time, forced to experience its relentless march forward while the true nature of reality remains hidden from us? If time is not fundamental, then what are we truly experiencing? Some physicists have proposed radical ideas, concepts that challenge not only physics but the very nature of existence. One such idea is that the entire universe, including time itself, is a hologram, a projection of a deeper reality we cannot perceive. If true, this would mean that our experience of time is not an absolute feature of the universe, but a byproduct of a deeper, hidden framework. Could this explain why atoms seem to exist beyond time, unaffected by its flow? Could it mean that everything we know, everything we experience, is simply part of a much larger, much stranger reality? If atoms are truly free from time, then perhaps they hold the key to understanding the deepest secrets of the cosmos. Perhaps they are the evidence that time, as we perceive it, is nothing more than a mirage. And if that is true, then what else about our reality is an illusion? What else remains hidden, waiting to be uncovered? In the next section, we will explore the consequences of a universe without time. If time is an illusion, what does that mean for the future? Is the future already written, waiting to be revealed? Or is reality itself still in the process of being created? Could we one day break free from the prison of time, just as atoms seem to have done? The answers may be more unsettling than we ever imagined. If time is an illusion, what does that mean for the future? Is the future already written, waiting to be revealed? Or is reality itself still in the process of being created? These questions are not just philosophical. They cut to the very heart of physics, consciousness, and the fabric of existence itself. One of the most unsettling possibilities is that the future is already set, just like the past. In classical physics, if you know the exact position and velocity of every particle in the universe, you can calculate exactly what will happen at any moment in time. The past, present, and future are simply different frames of the same cosmic film strip. Nothing is truly random. Everything unfolds according to precise mathematical laws. If this is true, then free will is nothing more than an illusion. Every action you take, every thought you have, was predetermined at the moment the universe was born. But then quantum mechanics arrived and everything changed. Unlike classical physics, quantum mechanics introduces uncertainty into the fabric of reality. A particle does not have a definite position until it is observed. An atom does not decay at a fixed moment. It follows only a probability distribution. The universe is not a clockwork machine, but something far stranger, governed by chance and possibility. This raises an even deeper question. If the future is not determined, if atoms do not follow a fixed script, then what exactly is the future? Does it already exist, waiting to unfold, or is it being created moment by moment? Some physicists believe that time does not truly flow at all. Instead, all moments in time, the past, the present, and the future, exist simultaneously in what is known as the block universe theory. According to this view, time is like a frozen landscape, with every moment already laid out. The reason we experience time as moving forward is simply because our consciousness moves through the landscape in a particular direction. Imagine flipping through a book one page at a time, believing that the story is unfolding, when in reality the entire book already exists. If this is true, then what does it mean for atoms? Are they simply existing in every possible moment at once, completely unaware of time's progression? If we could somehow change our perspective, could we see the entire past and future all at once, just as an atom might? But there is another possibility, one even stranger. What if time is not a fixed landscape, but something fluid, something that is still being written? Could the act of observation, the process of measuring reality, actually be creating time itself? Quantum mechanics suggests that reality does not fully exist until it is observed. The famous Schrödinger's cat thought experiment illustrates this idea perfectly. A cat is placed in a sealed box with a mechanism that has a 50% chance of releasing poison. According to quantum mechanics, until someone looks inside the box, the cat is neither alive nor dead. It exists in both states simultaneously. Only when an observer opens the box does the cat's fate become real. If this applies to time itself, then the future is not something that already exists. It is something that is created by observation. Until a moment arrives, it does not exist. If we never observe it, does it remain in a state of possibility forever? And if that is true, what does it mean for atoms? Could it be that, on the smallest scale, atoms are not simply moving through time, but actually determining what time is? Could time itself be nothing more than a byproduct of atomic interactions, something that only emerges when enough atoms come together to create a complex system? If atoms are immune to time, and if time is something that emerges only under certain conditions, then what would happen if we could manipulate those conditions? Could we engineer a reality where time no longer applies? Some physicists believe that quantum mechanics and relativity might one day allow us to manipulate time itself. The idea of time travel, once the domain of science fiction, is now being taken seriously by some of the greatest minds in physics. The equations of general relativity allow for the existence of closed time-like curves, paths through space-time that could, in theory, loop back on themselves, creating a way to travel into the past. But if atoms do not experience time the way we do, then what would time travel even mean? Would we be traveling through time, or would we simply be changing our perception of time? Could it be that the key to time travel is not moving forward or backward in time, but stepping outside of time altogether, into the same timeless state that atoms already seem to inhabit? And if we could step outside of time, what would we see? Would we witness all of history at once? Would we see the future laid out before us? Or would we exist in a state of eternal present, where time has no meaning at all? If time is an emergent property, if it arises only when we observe the universe in a particular way, then could it be that we are creating time simply by experiencing it? Could it be that time is nothing more than a projection, a construct that our minds impose on reality in order to make sense of it? This idea is not as far-fetched as it may seem. Some physicists believe that time might be an illusion created by the way our brains process information. In reality, there may be no distinction between past, present, and future. All moments may exist simultaneously, but our consciousness can only experience them in sequence. If this is true, then atoms are not trapped in time. Instead, they are free from it. They exist in a state that is beyond time, a state where all possibilities exist at once. And if atoms, the fundamental building blocks of everything, exist in this state, then perhaps on some level we do too. Could it be that our perception of time is what binds us to it? That if we could somehow alter our perception, we could experience reality in an entirely different way? Could it be that time is not something we are trapped in, but something we have created for ourselves? In the next section, we will explore the implications of this idea. If time is not fundamental, and if atoms are free from time's constraints, then what does this mean for the universe itself? Is the universe eternal, existing beyond time? Or is time an essential part of its structure? And if time is not real, then what is the true nature of reality itself? The answers may be more profound than we ever imagined. If time is not fundamental, then what does that mean for the universe itself? Is the cosmos an eternal, unchanging entity where all moments exist simultaneously? Or is time an essential part of its structure, woven into the fabric of reality? These questions have fascinated physicists and philosophers alike, and the answers may redefine everything we think we know about existence. One of the biggest clues about time's true nature comes from the very beginning of the universe, the moment we call the Big Bang. According to modern cosmology, the universe began as an infinitely small, infinitely dense singularity where all matter, energy, space, and time were compressed into a single point. Then, in an instant, everything expanded outward. But if time itself began at the Big Bang, then what came before? This is where things get complicated. Many scientists believe that asking what came before the Big Bang is meaningless, because time itself did not exist prior to that moment. Without time, there is no before. It is as if asking what lies north of the North Pole. There simply is no direction to go. But is that really the case? Could time have existed before the Big Bang in some form? Some theories suggest that our universe is just one of many in a vast multiverse, where time may exist in different ways, or even not at all. Other models propose that the universe undergoes endless cycles of expansion and contraction, meaning that the Big Bang was not the beginning of time, but merely the latest in a series of cosmic rebirths. If time is just a feature of our universe, emerging only under certain conditions, then it raises a profound question. Could there be places or entire realities where time does not exist at all? Could there be regions of the cosmos hidden beyond our reach, where atoms exist in a state of timelessness, free from the flow of cause and effect? And if time is an illusion, a byproduct of perception, then how does that perception arise? What is it that makes us experience time as linear when the universe may not function that way at all? One possible answer comes from a surprising place: quantum mechanics. At the subatomic level, particles do not seem to follow a strict timeline. They exist in superposition, meaning they can be in multiple states at once, only settling into a definite state when measured. Some physicists believe this suggests that time itself is not a fundamental property of reality, but something that emerges from the way quantum systems interact. If this is true, then what we perceive as the passage of time might be nothing more than the result of quantum decoherence, the process by which quantum possibilities collapse into definite outcomes. In other words, time may not be an independent feature of the universe, but a side effect of how information is processed at the quantum level. This brings us to another mystery. If time emerges from quantum interactions, then could it be possible to manipulate those interactions to control time itself? Could we slow it down, speed it up, or even stop it altogether? Science fiction has long explored the idea of time travel, but some physicists believe it may not be entirely out of reach. The concept of closed time-like curves, allowed by Einstein's equations of general relativity, suggests that under certain conditions, such as near a rotating black hole, it may be possible to loop back to an earlier point in time. But if atoms themselves are not bound by time, would they even recognize the difference? Would an atom know it had traveled back in time, or would it simply continue existing as it always has? And if time can be manipulated, then what does that mean for causality, the principle that cause must come before effect? Could time loops allow events to influence their own past? Could atoms somehow interact with themselves across different points in time? Some experiments suggest that this might not be as far-fetched as it sounds. The famous delayed choice quantum eraser experiment, for example, appears to show that a decision made in the present can retroactively affect the outcome of an event in the past. In this experiment, particles behave differently depending on whether information about their path is erased or retained, even if the choice to erase the information is made after the particle has already passed through a measurement apparatus. This suggests that quantum systems do not simply move forward in time, but may be influenced by events that have not yet occurred. Could it be that time is not just flexible, but reversible? Could atoms be moving both forward and backward in time simultaneously, existing in a state where past and future are indistinguishable? If that is the case, then what does it mean for us? If atoms, the building blocks of everything, are not bound by time, then why do we experience time so differently? One possibility is that consciousness itself plays a role in shaping our experience of time. Some theories suggest that time exists because we observe it, that our minds create a sense of past and future in order to process reality in a way that makes sense. If this is true, then the experience of time might be fundamentally different for different forms of intelligence. An artificial intelligence, for example, might process time in a completely different way than a human brain. Could there be beings in the universe that experience all of time simultaneously, much like an atom might? And if we could somehow alter our own perception of time, could we experience reality in the same way? Could we learn to step outside of time, to see the universe as it truly is, without past, present, or future? These questions bring us to one of the most profound implications of all. If time is not fundamental, if it is something that emerges from quantum mechanics, entropy, and observation, then what happens when we die? If our consciousness is tied to time, and time is an illusion, then is death an illusion as well? Could there be a state of existence beyond time, where the boundaries between past and future dissolve completely? Some physicists believe that the key to understanding time and what lies beyond it may come from a new theory that unites quantum mechanics and relativity. The search for a theory of everything has led scientists to explore radical ideas, from loop quantum gravity to string theory, each of which suggests that time may be far stranger than we ever imagined. One of the most mind-bending proposals is that time is not a fundamental part of the universe at all, but a holographic projection, an emergent property of deeper underlying physics that we do not yet fully understand. If true, this would mean that time, space, and even reality itself are all part of a deeper hidden order, one that may operate outside of time as we know it. If atoms are truly beyond time, then they may hold the key to unlocking these mysteries. They may provide the answer to one of the oldest questions in human history. What is the nature of existence itself? In the next section, we will explore what this means for the future of physics, consciousness, and our understanding of reality. If time is an illusion, then what else about our world is not as it seems? Could we one day develop the technology to escape the limits of time itself? And if we could, what would that mean for humanity's place in the universe? The answers may be more extraordinary than we ever imagined. If time is an illusion, a construct shaped by entropy, quantum mechanics, and observation, then what happens when we start to manipulate it? What if time is not something we simply experience, but something we can control? For centuries, the idea of time travel has captivated the human imagination. From ancient myths of gods who could step outside of time to modern science fiction depictions of wormholes, paradoxes, and alternate timelines, we have always been fascinated by the idea of escaping time's grip. But if time is not fundamental, if it is something that emerges from deeper quantum interactions, Then could time travel be more than just fantasy? Could it be a hidden feature of the universe waiting to be unlocked? To answer this, we must return to one of the most bizarre aspects of quantum mechanics: entanglement. Quantum entanglement allows two particles to become linked in such a way that they instantly affect each other, no matter how far apart they are. If one particle is measured, the other responds immediately, as if distance, and perhaps time, does not matter. Some physicists believe that entanglement is not just a connection through space, but also through time. If true, this would mean that information is not bound by the forward progression of time as we experience it. It could mean that events in the present could influence the past, and vice versa, creating a universe where cause and effect are not as simple as they seem. But could we use this effect to send messages through time? Some researchers have proposed experiments to test whether entanglement could allow information to be transmitted backward in time. If this were possible, it would challenge everything we know about causality, the idea that the past determines the future. It could open the door to a world where the future influences the past just as much as the past influences the future. And yet, despite these possibilities, we never seem to witness obvious violations of causality. We do not see people receiving messages from the future or events unfolding in reverse. If time is flexible, then why does it seem to behave in such a rigid way in our daily lives? One possibility is that while time is not fundamental, it is still governed by deeper laws, laws that prevent paradoxes and maintain the illusion of a forward-moving reality. Some theories suggest that the universe has a built-in consistency principle, meaning that even if time loops or backward communication were possible, they could never create contradictions. In other words, even if you could send a message to the past, it would never be able to change anything in a way that would create a paradox. But what if time is even stranger than that? What if the reason we never see time behaving abnormally is because we are only experiencing one version of reality out of many? This brings us to another mind-bending idea, the concept of the many worlds interpretation of quantum mechanics. According to this theory, every quantum event that could have multiple outcomes actually results in all possible outcomes occurring, but in separate, parallel universes. If true, this would mean that every time an atom decays, every time a particle is measured, every time you make a decision, the universe splits into different timelines, each representing a different version of reality. If time is not fundamental, then could it be that what we perceive as the future is not a single fixed path, but an ever-branching tree of possibilities? Could it be that atoms, free from time's constraints, exist simultaneously in multiple versions of reality at once, choosing different fates depending on which universe we happen to be observing? And if that is the case, then what does it mean for us? Are we simply moving through one branch of a vast multiverse, unaware of the countless other versions of ourselves that exist in alternate timelines? Some physicists believe that time travel, if it were ever possible, would not allow someone to change the past, but instead to enter a different branch of the multiverse where a different outcome had already played out. This would mean that even if you could travel back in time, you would never be able to return to your original timeline. Instead, you would create a new reality, one where your actions in the past had changed history, but only in a different version of the universe. But even if this were true, there is still one major obstacle: the apparent one-way direction of time. While quantum mechanics allows for particles to behave in ways that seem time-independent, everything we observe on a macroscopic level follows the arrow of time dictated by entropy. Entropy is the one force in physics that seems to always move in one direction. It is why a glass shatters, but never unshatters. It is why heat spreads from a hot object to a cold one, but never the other way around. It is why our memories work in one direction, why we remember the past, but not the future. But could there be places in the universe where entropy works differently? Could there be regions where time, as we experience it, does not apply? Some scientists have speculated that in the deepest, coldest voids of space, far beyond the reach of galaxies, where entropy is near zero, time might behave in unexpected ways. In these voids, could there be pockets of reality where time does not move forward, where past and future blur together, where atoms exist in a state outside of time? And if such places exist, could we one day find a way to reach them? Could we step outside of time, just as atoms appear to do? This leads to an even more profound question, one that takes us beyond physics and into the realm of philosophy and consciousness. If atoms do not experience time, then is time something that only exists because we are here to perceive it? Could it be that consciousness itself creates time, imposing order on a universe that is, at its core, timeless? Some theories suggest that our perception of time is a result of how our brains process information. Unlike an atom, which exists in a timeless quantum state until observed, our minds require time to function. We process reality in sequential frames, one moment at a time, like a movie playing out before our eyes. But if our perception changed, could we experience reality differently? Could we exist in multiple moments at once, as atoms seem to do? If we ever find a way to manipulate our own perception of time, could we experience the past and future simultaneously? Could we transcend the limitations of time entirely? And if that is the case, then what does it mean for our understanding of reality? If time is an illusion, then what else about our existence is not as it seems? In the next section, we will explore the final frontier of time, what it means for the fate of the universe, for the possibility of time travel, and for our own existence beyond time. If atoms are free from time's grasp, then what is stopping us from achieving the same freedom? The answer may be more incredible than we ever imagined. If atoms exist outside of time, if their quantum properties allow them to persist unaffected by the relentless march of entropy, then what does this say about the ultimate fate of the universe? For billions of years, the cosmos has expanded, its galaxies drifting farther and farther apart as space itself stretches like an inflating balloon. But this expansion will not continue forever, not in the way we experience it today. Eventually, the fate of the universe will be sealed in one of three possible outcomes, each with its own implications for the nature of time itself. The first possibility is the Big Crunch, where the expansion of the universe slows, halts, and then reverses, pulling everything back into a final catastrophic collapse. In this scenario, time may not be eternal. It may have an end, just as it had a beginning. But if time can end, then what does that mean for the atoms that make up the universe? Would they be annihilated, or would they persist in some form, waiting for a new cycle of existence to begin? If atoms are beyond time, could they somehow escape the final collapse and exist in a reality beyond the boundaries of time itself? The second possibility is the Big Freeze, a future where the universe continues expanding forever, growing colder and more desolate as entropy increases. In this scenario, all stars will eventually burn out, black holes will slowly evaporate, and even the smallest remnants of atomic structure will fade into the void. If time is simply a measure of change, then what happens when nothing changes anymore? If entropy reaches its maximum state, does time itself come to a halt? Would the universe, after trillions of years, enter a state where nothing ever happens again? If so, could there still be something beyond this ultimate stillness, or would the concept of time itself cease to hold meaning? The third possibility is the Big Rip, an even stranger fate in which the expansion of the universe accelerates so rapidly that eventually even atoms themselves are torn apart by the stretching fabric of space. In this terrifying scenario, time would not simply end. It would be violently unraveled, ripped from the structure of existence itself. But here lies an even deeper mystery. If atoms do not experience time as we do, could they somehow persist even beyond this final catastrophe? Could the fundamental components of matter remain in some unrecognizable state, free from the destruction of space and time? No matter which of these fates unfolds, one thing is certain. The universe is not static. It is a living, changing entity, and its structure is inseparably tied to the concept of time. But if atoms exist in a timeless state, then are they truly part of this grand evolution, or are they something separate, something that exists beyond the constraints of time and space? This question forces us to confront something even more unsettling. If time is an illusion, if it emerges only under specific conditions, then is the universe itself an illusion? Could it be that everything we experience, motion, change, the passage of time, is nothing more than a perception created by our own limited understanding? Some physicists have begun to explore the idea that time may not be fundamental at all, that the laws of physics work just as well without it. In certain equations that describe the universe at its most fundamental level, time simply does not appear. It is not a necessary variable. If this is true, then what we perceive as time might not be an essential feature of reality, but an emergent phenomenon, something that only appears when we look at the universe from a particular perspective. Imagine a book. From your perspective, reading page by page, the story unfolds sequentially. But to someone who holds the entire book in their hands, the past, present, and future of the story exist all at once. Could the same be true of time itself? Could the entire history of the universe, from the Big Bang to its final fate, exist in a single timeless state, with our experience of time being nothing more than our way of moving through it? If so, then what does this mean for the very nature of existence? This is where the limits of physics blur into the realm of philosophy. If time is something we impose on reality rather than something inherent to it, then how much of what we call reality is truly objective? How much of our universe is simply a result of how we perceive it? And more importantly, if atoms are free from time, and if time is something we impose on the universe rather than something that fundamentally exists, then is it possible that we too are capable of stepping outside of time? Could we ever perceive reality in its true, timeless state? This is not just a question for physics, but for consciousness itself. If our perception of time is a function of the way our brains process information, then could there be a way to alter that perception? Could we train our minds to see beyond time, to experience the universe as it truly is? Certain neurological studies suggest that time perception is not as rigid as we think. In moments of extreme fear or stress, time seems to slow down. In deep states of meditation, time can seem to dissolve altogether. And some individuals who have undergone near-death experiences report a complete loss of time, as if they were outside of it altogether. Could it be that these moments offer a glimpse into the true nature of time, or rather the lack of it? Could they suggest that under the right conditions, consciousness itself can escape the illusion of time? And if so, what lies beyond? This is where the scientific and the mystical collide. Throughout history, countless traditions and belief systems have described states of consciousness where time does not exist, where past, present, and future are perceived as one. If physics is now beginning to suggest that time is an illusion, then could these ancient ideas hold some hidden truth? Could it be that our experience of time is simply a limitation of the way we perceive reality, and that in some deeper sense, we are already free from time's grasp? And if that is the case, then what are the implications for our understanding of life and death? If time is not real in the way we think it is, then is death truly an end? Or is it merely a transition into a different way of experiencing reality, one where time no longer applies? These are questions that stretch beyond science, into the very fabric of what it means to exist. If time is an illusion, then what else might be an illusion? If atoms are free from time, then what does that mean for us? Perhaps the key to understanding time is not found in equations, but in experience. Perhaps the next great leap in human understanding will not come from discovering new laws of physics, but from discovering new ways of seeing reality. Or perhaps in the end the truth is even stranger than we can imagine. If time is not fundamental, then what else about our universe is built on illusion? Could our entire understanding of existence be shaped by perceptual limits, just as time seems to be? We often assume that space and time form an inseparable fabric, the very stage on which reality plays out. But if time is not as real as we think, then what about space? Is it possible that space itself is just another emergent property, something that only exists because we observe it? To understand this, we need to look at one of the most controversial and fascinating ideas in modern physics, the holographic principle. The holographic principle suggests that everything we experience, the three-dimensional world around us, may actually be a projection from a lower-dimensional reality. Just as a hologram can encode three-dimensional information onto a two-dimensional surface, the entire universe may be a higher-dimensional projection of something much simpler. This idea is not just science fiction. It comes from attempts to solve one of the biggest paradoxes in physics. What happens to information that falls into a black hole? According to traditional understanding, anything that crosses the event horizon of a black hole is lost forever. But quantum mechanics tells us that information cannot simply disappear. It must be preserved in some form. The holographic principle suggests that, rather than being destroyed, this information is encoded on the surface of the black hole itself. If this is true, then the universe itself may work the same way. Everything we perceive, space, time, matter, could be encoded on the outer boundary of the cosmos, projected inward to create the reality we experience. But if space and time are just projections, then what does this mean for atoms? Are they truly fundamental, or are they also part of a deeper illusion? If time is a mirage, then are atoms simply manifestations of a reality that exists beyond space and time? This question becomes even more intriguing when we consider something called the wave function, the mathematical description of quantum states. In quantum mechanics, particles do not have definite positions or properties until they are measured. Instead, they exist in a wave-like state of probability, only choosing a specific state when observed. Some physicists believe that this wave function is not just a convenient mathematical tool. It may be the true underlying reality, with the physical world emerging from it only when observed. If this is the case, then what we think of as atoms may not be solid, distinct objects at all. They may be nothing more than fluctuations in an abstract mathematical field, materializing into existence only when measured. And if that is true, then what is it that collapses the wave function? What forces reality to take shape? Some interpretations suggest that observation itself, the act of measurement, is what causes the universe to choose one outcome over another. If this is true, then consciousness may play a role in shaping reality at the most fundamental level. If observation determines reality, then could it also determine time? Could it be that time itself only exists because we are here to perceive it? If so, then this raises an even more profound question. What happens to time when there is no observer? Imagine a universe with no conscious beings, no intelligence to perceive the passage of time. Would time still exist, or would it dissolve into an eternal quantum haze where nothing ever truly happens? Some theories suggest that the early universe may have existed in a timeless quantum state before time itself crystallized into being. If true, then time may not be something that has always existed. It may be something that emerged as the universe became more complex. But if time can emerge, then could it also disappear? If consciousness plays a role in time's existence, then what happens when there are no more conscious beings to experience it? If the universe eventually reaches a state of total entropy, where all energy is evenly distributed and no changes occur, then could time itself fade away? And if that happens, then what is left? What remains when time has no meaning? Perhaps the answer lies not in physics, but in perception itself. If time is something we impose on reality, then what does that say about the nature of experience? Could it be that our perception of time is merely a byproduct of the way our minds process information, something we create to make sense of an otherwise timeless reality? This idea is supported by the way we actually experience time. Our sense of time is not fixed. It speeds up when we are engaged, slows down when we are in danger, and seems to disappear altogether in deep states of meditation or unconsciousness. Some people who have had near-death experiences report feeling as though time no longer existed, as if they were suspended in a state of pure awareness. Could it be that this is the true nature of reality? That time is not something we are trapped in, but something we impose on ourselves? If so, then what are the implications for our understanding of life, death, and existence itself? If time is an illusion, then is death also an illusion? If we are not truly bound by time, then do we ever truly cease to exist, or do we simply transition into another way of experiencing reality, one beyond time's limits? And if time is something we create, then could we learn to control it? Could we one day develop the ability to perceive time differently, to step outside of its boundaries and see the universe as it truly is? Some ancient traditions suggest that this is possible. Throughout history, mystics, monks, and spiritual practitioners have described experiences in which time loses all meaning, in which they perceive reality as a vast, interconnected whole, unbound by the linear flow of past, present, and future. If physics is now suggesting that time is an illusion, could these ancient experiences hold a deeper truth? Perhaps the ultimate question is not whether time exists, but whether we have the ability to move beyond it. If atoms are not bound by time, and if consciousness plays a role in shaping reality, then is it possible that the next great step in human understanding will not come from technology, but from a shift in perception? If we could truly see beyond time, what would we find? Would we discover a universe where all possibilities exist at once? Would we see ourselves as beings not confined to a single timeline, but as something greater, something infinite? These are not just abstract ideas, they are questions that strike at the very heart of existence. If time is not real, then what is? If atoms do not experience time, then why do we? And most importantly, what happens when we finally break free from time's illusion? If time is not a fundamental part of reality, then what does that mean for everything we believe about existence? Could it be that time, rather than being the unshakable foundation of the universe, is nothing more than a fleeting illusion, something that applies only to our limited perspective? We assume that things begin and end because that is how we experience the world. But in a universe where time is not fundamental, what if beginnings and endings are just artifacts of human perception? What if everything that has ever happened and everything that ever will happen already exists, permanently woven into the structure of reality, waiting to be observed? This idea is not as far-fetched as it sounds. Some interpretations of quantum mechanics suggest that the entire history of the universe, past, present, and future, exists simultaneously. Instead of reality unfolding moment by moment, it may exist as a complete and unchanging whole, with our consciousness moving through it like a flashlight illuminating different points along a vast timeline. If this is true, then what does it mean to change something? If all of history already exists, then is change merely the act of shifting our perspective within an already determined structure? This idea leads to a profound question. If the future already exists, then do we have free will? Or are we simply following a predetermined path, believing we are making choices when, in reality, every decision we make has already been made? Some physicists argue that time is like a river. It flows in one direction, but we are carried along with it, unable to alter its course. Others suggest that time is more like a landscape, where all points exist at once, and our perception of movement is an illusion. If the latter is true, then could we one day develop the ability to see beyond the illusion, to experience time as it truly is? Certain experiments hint that this may be possible. Some studies in neuroscience suggest that the brain does not experience time in a linear fashion. Instead, It pieces together fragments of information, creating the illusion of continuity. Under extreme conditions, such as in deep meditation, near-death experiences, or altered states of consciousness, this illusion can break down, allowing individuals to experience a reality where time no longer applies. Could it be that our default state of consciousness is what keeps us bound to time? And if so, could altering our perception allow us to experience existence beyond time's constraints? This idea ties into a long-standing mystery in physics. Why does the universe appear to be fine-tuned for life? Many of the fundamental constants of nature, such as the strength of gravity, the charge of an electron, or the properties of atoms, are precisely set in a way that allows for the formation of stars, planets, and eventually, conscious beings. If any of these constants were even slightly different, the universe would be a vastly different place, one where life as we know it could not exist. Some scientists argue that this is simply a coincidence, the result of natural laws playing out over billions of years. But others propose a more radical explanation. What if the universe is fine-tuned because consciousness plays a role in its very structure? Quantum mechanics has already shown that observation influences reality. Could it be that consciousness itself shapes the fundamental nature of the universe, including time? If atoms exist beyond time, then does that mean our perception of time is something we impose onto reality? This idea brings us to one of the strangest and most controversial theories in modern physics: retrocausality. Retrocausality suggests that events in the future can influence the past, that time is not a one-way street but a two-way interaction where cause and effect can move in either direction. Some interpretations of quantum mechanics suggest that an event in the future could determine what happens in the past. If true, this would mean that time is not an absolute sequence, but a flexible and dynamic structure where the past, present, and future interact with one another. If retrocausality is real, then what are the implications? Could it mean that our future actions shape our present reality? Could atoms existing outside of time be influenced by events that have not yet occurred? And if the future is already written, then is there any way to change it? Or are we simply discovering a path that has already been set? Some experiments suggest that the nature of time may be even stranger than we imagined. In one study, researchers found that when a quantum system was set up to make a choice between two outcomes, the choice could be altered retroactively, even after the decision should have already been made. If time truly worked in a linear fashion, this should be impossible. And yet, the data suggests otherwise. If time is not linear, if the past and future are in constant dialogue with one another, then how much control do we really have over our destiny? Are we moving through time, or is time moving through us? Perhaps the ultimate question is not whether time is real, but whether we can step outside of it entirely. If atoms are not bound by time, and if our perception of time is simply a result of how we process reality, then is it possible that we too exist in a state beyond time without realizing it? Some thinkers have suggested that what we call life is merely the experience of moving through a predetermined structure of time, and what we call death is simply the transition to a different state of existence, one where time no longer applies. If time is an illusion, then does consciousness persist beyond it? This brings us to an even greater mystery. If time is not fundamental, then what is? What is the true nature of reality when stripped of the illusions of time and space? Some physicists believe that the answer lies in pure information. Instead of thinking of the universe as a collection of particles moving through space and time, some theories suggest that everything, matter, energy, even time itself, is simply information being processed in an infinitely complex system. If true, this would mean that what we experience as reality is simply one possible arrangement of information among an infinite number of possibilities. And if reality is just information, then what role does consciousness play in selecting which version of reality we experience? If time is not real in the way we think it is, then could we, as conscious beings, influence which version of reality we observe? Some experiments in quantum physics suggest that observation does not just passively record reality, it actively determines which version of reality comes into being. If that is true, then what does it mean for time? Could it be that we are not just experiencing time, but creating it as we go? And if that is the case, then what happens when we stop observing? Perhaps the deepest mystery is not what time is, but why we experience it at all. If atoms exist beyond time, then why don't we? The answers to these questions may lie not in physics alone, but in a deeper understanding of perception, consciousness, and the fundamental structure of reality itself. If time is not fundamental, then what does that mean for consciousness itself? Is the way we experience reality, moment by moment, just an illusion created by the brain? If atoms exist beyond time, then does consciousness also exist in a timeless state? These questions challenge everything we assume about existence. We think of ourselves as beings who live in the present, remember the past, and anticipate the future. But what if this linear experience of time is just a perceptual construct? What if consciousness is something far greater than we imagine, something that exists outside of time, only dipping into it temporarily? Some scientists believe that our experience of time is a function of memory and cognition rather than an absolute property of the universe. The brain does not receive reality in a continuous stream. It takes snapshots of the world and stitches them together to create a sense of fluid motion. If time were truly fundamental, we should be able to measure it in a way that is independent of our perception, but no such measurement exists. Time appears to be a subjective phenomenon, one that arises from the way we process information rather than something inherent to reality itself. If this is true, then what happens when we sleep? What happens when we lose consciousness? Where does time go? When we sleep, our sense of time vanishes. We do not experience 8 hours passing in real time. We simply wake up and register that time has passed. Similarly, people who experience total blackouts, comas, or deep anesthesia often report that it felt as though no time had passed at all. Could this suggest that consciousness is not bound to time in the way we assume? Could it mean that time is something we only experience when we are actively perceiving reality? If this is the case, then what does it mean for death?
If consciousness ceases, does time cease with it? If our perception of time is nothing more than a byproduct of brain function, then what happens when that function stops? Could it be that time does not exist at all from the perspective of a person who has died?
This raises an even deeper question. Does consciousness itself exist outside of time? One of the most mind-bending implications of quantum mechanics is that observation determines reality. Particles exist in a cloud of probability until they are measured, at which point they collapse into a definite state. This has led some to speculate that consciousness is not just a passive observer of the universe, but an active participant, one that plays a role in shaping the fundamental structure of reality itself.
Could it be that consciousness exists in a timeless state and only experiences time when interacting with the physical world? Could our perception of time be similar to playing a video game, where events are only rendered when we look at them?
This would explain why time only exists when we are aware of it. If no one is observing time, does it continue to exist? Or does it dissolve into the same quantum uncertainty that governs subatomic particles? This idea leads to another mystery, one that has been at the heart of human thought for centuries. If consciousness and time are intertwined, then what is the relationship between the mind and the universe itself? Some theories suggest that consciousness is not an individual phenomenon, but a fundamental property of the universe, something that exists beyond individual minds, beyond biological structures, and beyond time itself. If this is true, then what happens when we die? Does consciousness dissolve into nothingness, or does it simply shift to a different state, one that is not bound by time? Near-death experiences provide intriguing insights into this question. Many people who have been revived after clinical death report the same strange sensation. time no longer exists. They describe seeing their entire lives at once, not as a sequence of events, but as a simultaneous whole. Some even describe entering a state where past, present, and future blend together into a single moment, one that feels more real than anything they have ever known. Could it be that these experiences reveal something fundamental about reality? Could it be that time is an illusion that only applies to physical existence, and that once we are free from the body, we return to a state of timeless awareness? Some ancient traditions have described states of consciousness that transcend time, where individuals claim to experience the universe as a single, interconnected whole. Could these experiences offer a glimpse into the true nature of existence, a reality where time is nothing more than a temporary condition of human perception? If so, then what are we? Are we beings trapped in time, or are we something far greater, something that exists beyond time's illusion? If consciousness is not bound by time, then could it exist beyond the physical world entirely? Could it be that our perception of a linear timeline is only a temporary condition, one that applies only while we are living in this physical dimension? Some theories in quantum physics suggest that consciousness may be a fundamental force of the universe, not something produced by the brain, but something that exists independently of it. This idea, known as panpsychism, proposes that consciousness is not something that emerges from matter, but something that is embedded in the very fabric of reality. If this is true, then could it explain why time seems to disappear in deep states of awareness? Could it mean that when we stop observing time, we return to a state where time does not exist? This would radically change our understanding of existence. Instead of seeing life as a linear journey from birth to death, we might begin to see it as something cyclical, something that emerges from a timeless state, exists briefly within time, and then returns to a state beyond time. This idea aligns with some of the oldest spiritual traditions in human history. Many mystical traditions describe a reality where time is an illusion, where past, present, and future are all part of a single unified whole. Some ancient teachings even suggest that enlightenment is the process of awakening from the illusion of time, of recognizing that we were never truly bound by it in the first place. Could it be that time is not something we escape, but something we learn to see through? Could it be that the key to understanding reality is not in breaking free from time, but in realizing that we were never bound by it to begin with? This has profound implications for how we understand the universe, life, and even the nature of identity itself. If consciousness is timeless, then who are we really? Are we temporary beings born into time and then erased from existence? Or are we eternal observers experiencing different moments of reality while existing outside of it? And if we are, then what does that mean for everything we think we know? Perhaps our greatest limitation is not time itself, but the belief that we are trapped within it. Perhaps the truth is far stranger. Perhaps we are beings of infinite awareness, only temporarily experiencing the illusion of time. If time is an illusion, then what is waiting for us beyond it? Time has shaped everything we know. It has dictated the rise and fall of civilizations, the birth and death of stars, and the relentless forward motion of our own existence. It has governed our thoughts, our fears, our memories, and our dreams. And yet, despite its dominance, we are now faced with an extraordinary possibility that time itself may not be real in the way we have always believed. If atoms exist beyond time, if their fundamental nature is untouched by the passage of seconds, minutes, and hours, then what does that say about the reality we live in? Have we mistaken a perceptual experience for an absolute truth? Have we built our entire understanding of existence on an illusion? Perhaps time is nothing more than a construct, something that emerges from the way we observe the world, rather than something fundamental to the universe itself. If that is the case, then we have never been bound by time at all. We have only believed we were. This realization forces us to reconsider everything we think we know. If time is not what it seems, then what about space? What about matter? What about the very fabric of reality itself? Some of the greatest minds in history have wrestled with these questions. Einstein shattered the notion of absolute time, showing that it stretches and bends with gravity and velocity. Quantum mechanics further eroded the foundation of time, revealing a world where particles exist in a timeless state of probability, where the future can influence the past, and where entanglement suggests that distance itself may be an illusion. If these ideas are true, then what does it mean to be alive? If the universe is not bound by time, then is consciousness itself timeless? Are we not merely moving through time, but instead experiencing something that exists all at once, a vast, unchanging reality that we only perceive as unfolding moment by moment? This brings us to perhaps the most unsettling question of all. If time is an illusion, then what happens when it ends? We have long feared death because we believe it is the end of time for us. But if time is not fundamental, if it is simply a way of experiencing reality, then does anything truly end? If atoms do not age, if they persist beyond the rise and fall of galaxies, then could consciousness itself persist beyond time's illusion? Some have suggested that what we call death is merely a transition, a shift in awareness, a movement beyond the constraints of time. If time is nothing more than perception, then perhaps what we call the end is nothing more than the moment when our perspective changes. And if that is true, then what else might we have misunderstood? For centuries, mystics, philosophers, and spiritual traditions have described a universe where past, present, and future are one, where time is an illusion, and where consciousness exists beyond physical form. Could these ancient insights contain a hidden truth, one that physics is only now beginning to uncover? If time is a product of observation, then perhaps the greatest discovery of all will not be a new scientific breakthrough, but a shift in how we perceive reality. If we could break free from the illusion of time, what would we see? Would we discover that we have always existed, outside of time, unaware of our own timeless nature? Perhaps this is the final paradox. We are searching for a way to escape time, when in reality we were never trapped by it in the first place. Atoms do not experience time. They do not age, they do not decay unless acted upon, and they do not perceive a past or a future. If the building blocks of the universe are free from time's grip, then why do we assume that we are not? What if the only thing binding us to time is our belief in it? What if we are like shadows cast upon the surface of a river, mistaking the movement of the water for movement within ourselves? If time is an illusion, then reality itself may be something far more extraordinary than we ever imagined. The past may not be gone, the future may not be unwritten, and the present moment may be nothing more than a frame in a much larger eternal structure of existence. And if that is the case, then perhaps the greatest mystery is not time itself, but the way we experience it. Perhaps the greatest illusion of all is not time, but the belief that we are separate from it. And if we could change that belief, if we could learn to see through the illusion, then what might we discover waiting for us beyond time? Thank you for joining us on this extraordinary journey through the cosmos here on Frontiers of Infinity. If this glimpse into the unknown has sparked your curiosity, be sure to subscribe and join us each Friday at 7 p.m. Eastern, where we unravel the darkest mysteries of space.